All right, let's talk about a tiny, practically invisible component that is, no joke, the unsung hero of all our electronics. It's the silent guardian angel standing between your favorite gadgets and the wild, chaotic world of electricity.
I mean, have you ever really thought about that? You take your phone, this device that costs a small fortune, and you just plug it into a hole in the wall. You just trust it's going to be okay. But what's actually stopping a sudden jolt of power from turning that shiny new phone into a very, very expensive brick?
Well, to answer that, we've got to understand something about electricity itself. You see, the power that flows from our outlets and batteries, it's not this perfectly smooth, stable river we like to imagine. It's actually a pretty rough place for the delicate little circuits inside our devices.
There are constant ripples, little variations, and sometimes huge, sudden spikes in voltage. And as our electronics get smaller and faster and way more complex, they've only gotten more vulnerable to these fluctuations. They need a bodyguard, you know? Something designed specifically to take the hit.
And that, right there, brings us to the hero of our story, the Zener Diode. So, what's its big secret? Well, it's a special kind of semiconductor that's built with a very particular secret weapon, one that makes it the absolute perfect protector against voltage drama. And here it is. Yeah, I know, it doesn't look like much, does it? Just a tiny little component with two wires sticking out. But believe me, packed inside that simple little package is a clever bit of physics that basically makes our entire digital world possible.
Okay, so to get its secret, let's use a simple analogy. Think of a regular diode like a one-way street for electricity. Traffic, the current, can only flow forward. It's totally blocked from going backward. Now the Zener diode, it's also a one-way street, but here's the cool part. It has a special emergency exit, and that exit only opens when the reverse traffic, the voltage, gets too high and hits a very specific level. That little exit is the key to everything.
So, the special ability to open an emergency exit has a name. It's a phenomenon called breakdown. Now I know breakdown sounds like a really bad thing, right? Destructive, but for the Zener diode, it's a completely controlled, predictable, and incredibly useful trick. Now check this out. This graph really shows you what's going on. It's called an IV curve, and it just shows current versus voltage. See over on the right in the forward direction? It acts just like any normal diode. But look to the left in the reverse direction. As you push more voltage backward, nothing happens, and then bam! The current just plummets straight down in an almost perfect vertical line. That dramatic drop, that's the magic, that's the breakdown region. And this right here is the whole point. In that breakdown region, the Zener diode can let a whole range of current flow through it, all while holding the voltage at a nearly rock-solid constant level. That's its superpower, the ability to lock voltage in place and say, "You shall not pass."
And get this, it's a really cool detail. This breakdown isn't even just one single process. For diodes rated below about 5 volts, it's actually caused by a quantum tunneling thing called the Zener effect. But for diodes rated above 5 volts, it's a totally different process called avalanche breakdown. It's where electrons literally start a chain reaction. So you have two different bits of physics being used to get the same amazing result. How cool is that?
So, we have this component with a superpower. How do we actually use it? Well, its most common job, by far, is to build a simple but incredibly powerful voltage regulator.
Okay, don't let the diagram look intimidating. It's actually super simple. You see the Zener diode there? It's placed in parallel with the thing we want to protect. We call that the load. And notice how it's installed backward? It's sitting there in its reverse position, just waiting to do its thing. The best way to think about it is like a pressure relief valve, but for electricity. As long as the voltage is normal and stable, the valve is closed, and the Zener just chills out. But the second the voltage spikes too high, that valve opens up and the Zener shunts, or diverts, all that excess electrical pressure safely away from your sensitive circuits. The voltage at the load stays locked in at the Zener's breakdown voltage, and everything stays safe and sound.
But this idea of clamping voltage isn't just for little wobbles from a power supply. Oh no, it can be scaled up to protect our gear from much bigger, much more violent threats.
You know, our gadgets live in a surprisingly dangerous electrical world. They face massive power surges from things like lightning, they face tiny but deadly zaps from static electricity, and they get hit with spikes every single time big motors or transformers get switched on or off somewhere on the power grid. And just to give you an idea of the scale we're talking about, a single typical lightning strike can carry a peak current of 20,000 amps. Let that sink in for a second. That is an unbelievable amount of energy that needs to be controlled in a matter of nanoseconds.
It's like the engineers at On Semiconductor put it, you just can't expect a modern microchip to survive in that kind of environment all by itself. It needs help. It needs backup from specialized components built just to handle these kinds of dangers.
So at the end of the day, that's what Zener diodes and their heavy-duty cousins do. They're like sacrificial guardians. They clip the voltage at a safe level and then shunt all that dangerous surge of current, giving it a safe path to go to ground, anywhere but the delicate circuits it was about to destroy.
The Zener diode is just a perfect example of the incredible invisible engineering that makes our technology work so reliably. It really makes you wonder, doesn't it? What other tiny, unsung heroes are silently at work inside the devices you use every single day? Some to think about. Thanks for joining us.